In this class, we're looking at linear inequalities as a continuation of our revision series for WAEC students. And since it is a revision class, I will go into question right away. The first question here says find the range of values of x for which 1 minus 6x is greater than 5. So if 1 minus 6x is greater than 5, just like we will do in equation, here we'll collect like terms. This 1 and 5 are alike since both of them are constant terms. I'm going to move this 1 to the other side so that we left with negative 6s is greater than 5. And this is plus 1. When you cross it to this side, it becomes minus 1, right? So negative 6s is greater than 5 minus 1 is 4. You find the value of x, we divide both sides by negative 6. And in inequalities, when dividing by a negative number, the sign of inequality will reverse, so that instead of greater than 9, it becomes less than 2. X is less than 4 minus 4 over 6, which we can reduce 2 here to 2 here to. Hence, x is less than negative 2 over 3. But the question says range of values of x for which this is equal to, meaning in inequality you cannot have an exact answer. So anything that is less than negative 2 over 3 satisfies the inequality. That is why the word range of values. From this negative 2 over 3 down, so if I to represent that on the number line, let's assume this is 0, this is negative 1, this is negative 2, and so on and so forth. Then this is 1, this is 2, and so on and so forth. This negative 2 over 3 is not 1, so it should be somewhere here. Sorry, I painted that. I'm not supposed to paint it. It's supposed to be an over shape circle only without the paint. Then I'll point an arrow like this to show that anything from B down here satisfies the inequality. That is what they mean by the range of values of x, which satisfies. Although they didn't ask us to represent that on a number line, I'm just doing this for the sake of explanation. Okay? So now the next question is a solve 3 over 4 x minus 4 over 5 x is less than or equal to 1 over 2. For this fraction, to clear the fraction, I'm going to look for the LCM of 4, 5, and 2. It is a number that divides 4, 5, and 2. That should be 20. I'm going to multiply each term of this inequality by 20 so I can clear the fraction. 20 multiplied by 3 over 4x minus 20 multiplied by 4 over 5x is less than or equal to 20 multiplied by 1 over 2. So that's 4 here 1, 4 here 5, 5 here 1, 5 here 4, 2 here 1, 2 here 10. Therefore, 5 times 3x is 15x minus 4 times 4x is 16x less than or equal to 10 times 1 is 10. 15x minus 16x is negative x is less than or equal to 10. Divide both sides by negative 1 to get rid of this negative there. And remember that when dividing by a negative sign, we reverse the sign of inequality. So s is, instead of less than 9, become greater than or equal to negative 10. So if I were to represent this again on the number line, we have something like this. Let's assume this is my 0, but I have more of negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's assume this is my negative 10. This negative 1, negative 2, and so on and so on down to negative 10. Then this is less than or equal to, meaning negative 10 is inclusive. Negative 10 also satisfies that inequality. So for that reason, we are going to paint the circle and then point an arrow. Anything greater than -10 also satisfy that. I point an arrow, all of this number like this down to positive infinity satisfy the inequality. In example 8, which is the WAEC past frequency of the inequality 5 minus 3x over 2 greater or equal to 2x plus 3 over 5. And this is a fraction. I would need to clear the fraction by multiplying both sides or each term of this inequality by the LCM of 2 and 5. The LCM of 2 and 5 is 10. So 10 multiplied by 5 minus 3x over 2 is greater or equal to 10 multiplied by 2x plus 3 over 5. 5 here 1, 5 here 2, 2 here 1, 2 here 5. Another way we can do that is to cross multiply right away. This time, then you can see we still have the same 5 multiplying it. And this time, we also have the same 2 multiplying it. So now let's distribute this 5. What do I mean by that? I will multiply each term in the bracket by the term outside. Do it here, also do it here. So 5 times 5 is 25. 5 times -3, that is -15x, greater or equal to 2 times 2x is 4x, and 2 times 3 is 6. Collecting items, this -15x and 4x are alike, so we bring them together. That will be -15x. This is plus 4x. When it crosses the sign of inequality, it becomes -4x. If greater or equal to, and this 6 right here, this 25 also will cross over to 6. This is plus 25. When it crosses this sign, it becomes -25. Now -15x minus 4x is -19x, greater or equal to 6 minus 25 is -19. Divide both sides by -19, so we can get rid of this by -19. This will go. Now remember that whenever we divide by a negative sign, the sign of inequality will change. So we're going to find the sign instead of greater than or equal to, it becomes less than or equal to. Now -19 divided by -19 is 1. So s is less than or equal to 1. Again, if you are asked to represent this on a number line, you have this. This is my 0, this is my 1, this is my 2, this is my 3, down to positive infinity, then also to negative infinity, -1, -2, and so on and so forth. So x is less than or equal to 1, meaning less than or equal to 1 implies that 1 also satisfies that inequality. So we are going to paint the circle, then anything less than 1, which are all the set of numbers down here, satisfy that inequality. So that is that. Then we have example 9 here, which wants us to represent it on a number line. -6 is less than or equal to less than s is less than 2. So you draw your number line, 0, 1, 2, 3, and 4, and so on and so forth. Let me extend this since I have up to -6, -1, -2, -3, -4, -5, -6, -7, and so on and so forth. Now the same -6 is less than or equal to x. So -6 is inclusive, means it is less than or equal, so we paint it. Now, when it is only less than or only greater than, just draw ordinary circle. Do not paint. Painting here implies that the number you are painting on satisfies that inequality. That number is included in the range of answer that satisfies that inequality. So we're going to paint this negative 6, and then the next value there is 2. But here we will not paint it because 2 is not inclusive, because x is less than 2. We will draw a line to connect these two points. Draw line. That is the representation of this inequality on a number line. That is negative 6 is less than or equal to x, and x is less than 2. And finally, we have some WAEC question here. Example 7 says solve the inequality. That's number 7 rather not example 7. If 3 times 2x plus 1 is greater or equal to 1 over 3 times 2x minus 9. Before we can do anything here, we need to distribute the number outside the bracket, that is multiplying the number outside the bracket by each term in the bracket. So 3 times 2x is 6x, and 3 times 1 is 3, greater or equal to 1 over 3 times 2x is 2x over 3, 1 over 3 times negative 9 is 3. Look at this, 1 over 3 times 9. 3 here 1, 3 here 3, and 3 times 1 is 3. I have that here. Okay, now with this, we need to collect items. 6x and 2x over 3 are alike because both of them are terms in x. This is plus 2x over 3. When it crosses the sign of inequality, it becomes minus 2x over 3. Greater than or equal to negative 3. This is positive 3 here. When it crosses the sign of inequality, it becomes negative 3. Now, solving this fraction here, we're going to look for LCM of 1 and 3, which is 3 itself. 3 divided by 1 is 3. Multiplied by this 6 is 18x. Then minus 3 divided by 3, 1. Multiplied by 2 is 2x. All over 3 is greater than or equal to negative 3, negative 3. That's minus 3 minus 3 is minus 6. And this is over 1. To cross multiply, to get rid of this 3 here, I have 18x minus 2x is 16x. Greater or equal to 3 times negative 6 is negative 18. So divide both sides by 16. X therefore is greater or equal to negative 18 over 16. If they ask us to represent on a number line below, just to solve the inequality. Okay, now we'll move on to the next one. First, solve the inequality n minus 2 over 3 minus x plus 1 over 2 is greater than 2. This 2 is over 1. I want to clear the fractions, so I'm going to multiply each term of the inequality by the LCM of 3 and 2, which is 6. So 6 multiplied by x minus 2 over 3 minus 6 multiplied by x plus 2 over 2 is greater than 6 multiplied by 2 over 1. So 2 here 1, 2 here 3, 3 here 1, 3 here 2. Distributing the terms outside the bracket, as 2 times this is 2x, and 2 times this is 4, minus 3 times this is 3x, and minus times plus is minus, 3 times this is 6, greater than 6 times this is 12. Collecting items, these and these are terms in x, so bring them together 2x minus 3x, and minus 4 minus 6 is greater than 4. 2x minus 3x is negative x, minus 4 minus 6 is minus 10, greater than 4. Minus s is therefore greater than 12. This minus 10 when crossing this side becomes plus 10. Minus 10 rather, when crossing the side becomes 10. Minus s therefore greater than 12 plus 10 is 22. To get rid of this minus, I will divide both sides by minus 1. Minus 1. And when dividing by a negative number, we reverse the sign of inequality. So instead of greater than, it becomes less than. 22 divided by our negative 1 is negative 22. Example 9 of question 9 6. Solve the inequality x plus 1 whole number 1 over 2x is greater than or equal to 1 whole number 2 over 3x minus 1 whole number 1 over 6. And show the result on a line graph. Okay, first of all, these mixed numbers, let's convert them to improper fractions. So I have x plus 1 times 2 is 2 plus 1 3. 3x over 2 greater or equal to 1 times 3 is 3 plus this 5 x over 3 minus 1 times this is 6 plus this 7 over 6. Okay, to clear this fraction, we're going to multiply each term of this inequality by the LCM of the denominator. The LCM of this denominator, 2, 3, and 6 is 6 itself. So I'm going to multiply each term of this inequality by 6. I have 6 multiplied by x over 1 plus 6 multiplied by 3x over 2 is greater or equal to 6 multiplied by 5x over 3 minus 6 multiplied by 6, 7 over 6 rather. So 6 will cancel 6. 3 here 1, 3 here 2, 2 here 1, 2 here 3. 6 times x is 6x. 3 times 3x is 9x. Is greater or equal to 2 times 5x is 10x minus 7 rather. 6x plus 9x is 15x. Is greater or equal to 10x minus 7 collecting items. This plus 10 when it crosses this side it becomes minus 10. So I'll have 15x minus 10x is greater or equal to negative 7. 15 minus 10x is 5x greater or equal to negative 7. Divide both sides by 5. And 5 s therefore is greater or equal to negative 7 over 5. This is negative 1 whole number 2 over 5. That is greater than or equal to. So now we are to represent that on a line graph. That's question B. How do we represent this on a line graph? Draw the number line. That is 0 over here. We are representing a negative number, so that means focus on the negative side. This is minus 1, minus 2, minus 3. My number is negative 1 whole number 2 over 3. This is 1, so 1 whole number 2 over 3 should be here. Somewhere here. So it's less than or greater than rather or equal to. Let me write that very well. Greater than or equal to. So we are going to paint it because this number that we want to show is inclusive. So if s is greater, or equal to negative 1 whole number 2 over 3, 2 over 5 rather. All numbers from this place, all would satisfy the inequality. So we put x here. This is the range of value that satisfies that inequality from negative 1 whole number 2 over 3 to positive infinity. Satisfy that inequality. We put an arrow there to show that the number continues left and right indefinitely. So finally, question 10. To solve the inequality, we have 1 over 3 x plus 5 over 8 is greater or equal to 1 over 2x minus 2 over 24. Again, to solve this, let's start by clearing the fraction. And to do that, we are going to multiply each term of this inequality by the LCM of 3, 8, 2, and 24, which is 24 itself. So multiplying each term of the inequality by 24, I will have 24 times 1 over 3x plus 24 times 5 over 8 is greater or equal to 24 times 1 over 2x minus 24 times 2 over 24. 24 will cancel 24. 2 here 1, 2 here 12. 8 here 1, 8 here 3. 3 here 1, 3 here 8. So we have something equal to, it's not supposed to be equal to that. 8 times x is 8x plus 3 times 5 is 15 is greater or equal to 12 times x is 12x and 12, okay, minus 2 right there. Collecting items, we have 8x. This plus 12x when it crosses this and becomes minus 12x is greater or equal to negative 2. This plus 15 when it crosses it becomes minus 15. 8x minus 12x is minus 4x greater or equal to minus 2 minus 15 is minus 17. Divide both sides by minus 4. Minus 4 if we cancel. And remember, when we divide by a negative number, we reverse the sign of inequality. Minus we cancel minus. So 17 over 4. 17 over 4 is 4 whole number 1 over 4.